All right. Let's see. Let's go. In the chat here. All right, there we are. Good morning, first of all. Welcome. Morning if it's morning. Good morning for me. But good day anyway, no matter what time it is. Let me. There we are. Yes. So welcome, first of all, and thank you for watching. If you are new, don't know who I am, my name is Tim. I go by FoamyGuy on GitHub and Discord, and I typically stream around this time each week, working on some stuff related to CircuitPython. If you don't know what CircuitPython is, you can find out more about it here at the main website for the project, which is circuitpython.org, which is what is on the screen now, right? Yeah, we have the screen showing. Yeah, okay. It is, if you are new and don't know, it's basically a way to program microcontrollers. Microcontrollers are tiny computers, like all of these ones over here on the downloads page. These are essentially a little chip that's on a board. Lots of them often come with broken out pins that you can connect other stuff to, although there are some more purpose-built ones as well, which have less pins broken out and more just stuff built in, like these PyPortal devices, which are kind of like little tablet type devices. They have a touch screen on it. They have a couple peripherals. They do have a few places where you can plug in other things, but for the most part, they come with what's on them, and that is the majority of what you do with them. Whereas others are much more generalized. You really can plug in whatever you want to any of these pins here. If you choose to use CircuitPython to program these devices, which is just one of the many ways you can do it, when you plug it into your computer, usually with a USB cable, it shows up like a thumb drive. You edit a Python code file on that thumb drive. When you save it, the computer in the little chip here will actually interpret and execute that Python code for you. And you can then, from your code, interact with whatever you have connected to those pins. Speaking of the PyPortal, I chose it just to start off with a quick, I guess, peek at one of the things I was playing with the other day, which is this procedural animations using Fabric. All credit to this video from Programming Chaos on YouTube. This was a really great resource for this basic animation, which turned out looking like this. I will say the camera struggles keeping up with this. There's really only one sort of instance of this line of dots, whereas the camera kind of shows some ghosty ones there because of the speed and the refresh rate and stuff. But this was fun to follow along with. I am thinking potentially about doing. I've found a few of these things on YouTube lately, and it seems like there's a bunch out there. I've done one from this person as well, the coding train. It was pretty cool. There seem to be a fair number of these out there on YouTube, like graphics demonstrations of different algorithms. Maybe we'll start doing kind of a series of implementing these in CircuitPython. Like this was in, I think both of these actually that I did, they used Scratch. So I was not following one-to-one with the code, but kind of like pause for a second and convert what they did in Scratch over to CircuitPython. In this case, I used vector.io circles and have a line of them there, and this inverse kinematics fabric function allows it to kind of do this sort of tentacle wavy action that looks kind of, I guess, organic or like physically accurate for a certain kind of floppy tentacle, which is pretty cool. You can also do snakes and some other stuff. If you don't, like I have it anchored to the bottom there, so this one won't move, but you can also make it kind of freeform and it can sort of slither its way around the screen, which is pretty cool as well. So maybe we'll play with that some on a future stream. But the real thing that I do want to get back to today is the USB host stuff I was working on last week. If you watched last week's stream, then you may know I was using this USB host Feather. I have this sort of generic PlayStation 3 controller that I picked up from Micro Center for like $10 or $15 or something like that. I'm not really going to need the camera because I can't really show too much. We're going to go without the screen for a while. One of the things I was doing last week was I jumped straight into also having a screen hooked up to this Feather. And at some point I started wondering, like, is that part of my problem? And I removed the screen from the equation, and it turns out I don't really think that it was part of the problem. But I do think that it is wise to just keep it simple and not use the screen for now, because we don't really need it. Let's plug this in. Hey, thanks for the follow on Twitch, my friend. Lofi247. Appreciate it. Okay, so we have that, and I think that so if you did not watch last week, then you may not have seen. Well, you didn't see, didn't watch. But last week we were having some trouble with this. I jumped right in. I was using the screen, and we were getting these hard faults. And I think that I made some progress on figuring out what the hard faults were. So hopefully we can avoid that this week, and I will fill you in. So this is basically more or less the code we were working with last week. Like I said, I had the display, we were making labels, we were printing to the screen, we were doing all kinds of other stuff. But in its core, it was essentially this, which is like we can, this part of it is in a Boolean. You can turn it on and off with this here, but this part of it will scan for USB devices, and it will print out verbose information about all the ones it finds. This will just grab the first one, or actually the last one, technically. We'll grab the last one. Realistically, I only have one plugged in, so it doesn't matter. But this is an iterator, so we have to loop it. We can't just say, give me the first one, or the last one, or whatever. We have to loop it. So we loop it. We get the only one, in my case, that's plugged in. We set configuration so that we can actually do USB host stuff with it. We do this because I think it's required and important. It was in the example I found. I haven't tried removing it, but I suspect it's probably pretty important. I think it's to do with, like, make sure I will say the example I found this from, it's a keyboard example, and I don't know if it applies to game controllers the same way. So we might actually be fine if we remove it, but I'm not going to mess with it for now. I think this is probably like detaching it so that like the CircuitPython serial is not trying to interact with the keyboard. Because if you just plug in a keyboard to a device, a CircuitPython device with USB host, and everything works properly, the keyboard will actually be hooked up for you so that you can, like, type into the terminal, the CircuitPython terminal. And I think this is like unhooking it from that. In our case, it's not a keyboard, it's a gamepad. So I don't know for sure if it matters, but in any case, this is actually where the issue, I believe, lied last week. I believe this is where our problem was last week. You can kind of see the remnants in the comment here. We had this holding 8 bytes. This actually said 8 right here. And I think that was the problem. So this is a buffer, which we are going to read data into from the device. We say device read, we tell it the endpoint or whatever, the address we want to read. And then we give it the buffer. That's this buffer right here. and it fills the buffer with data from the device. And it returns count, which this is the part that I did not really get into last week, I don't think. I eventually started printing out count, and what I found was, even though this was 8, the buffer was 8, count was printing 27. So I got the suspicion that really what's happening is, well, what was happening is we had a buffer with 8 bytes of storage, 8, I don't know if they're bytes, they're really ents, I guess, but 8 spaces. We were reading 27 things, so all of the ones past the first 8 were going to just somewhere else in memory, which is where the hard faults, I think, were coming from. Because every time we got a hard fault, it was a memory access instruction error or something. I don't remember the exact wording. But every time we got a hard fault, it was something about memory. And I think we were probably just clobbering, 19 bytes of memory randomly with whatever was coming in from the controller. And as I was changing the rest of the script, that was affecting what was in memory and where. So sometimes when we clobbered that memory, we hard faulted. Other times when we clobbered that memory, we didn't, and it seemed like it was working. But ultimately, I think that was our problem. What's up, DJ Devin? Nice to see you this morning. And coffee cheers. So that, I think, is the key. I found that mine was returning 27. This particular gamepad was returning 27, but I did actually also go and look into it, and I believe that I'll close this. Again, this is really cool, though. You should take a look at this if you're interested in graphic animation stuff. I went and looked up like USB host report maximum data size or something like this. And I found something that made me think it was 64. This was not it, because this is talking about 64K. What is the size? I don't know. I don't remember exactly what I searched, and I don't know the proper terminology for what I'm actually talking about, which makes it tough. What is the maximum size for USB port data? 64 bytes. This, I think, is what I found. 64 byte packet. So I think if we were to just make this 64, then we should be safe on any device. I'm avoiding fixing my toilet flush system here. Uh-oh. Hopefully that's nothing. Hopefully that's nothing too major, at least. I will say, like, toilets. It's bad when they are messed up, obviously, but they are remarkably simple for what they are. It's kind of crazy, like. It's kind of crazy how simple the mechanisms are. USB HID makes your head hurt. Yes, definitely. And that's where we're at last week, is like, I was trying to simplify it, and even simplifying it, we were still running into hard faults and stuff, so I've simplified it even more, and since discovered this fact that 64 bytes is the maximum, and then this other fact, which is that I believe that this device.read, I believe this is clobbering. So, like, in my mind, it's a bug. I guess the true thing is, like, I don't know the intention of device.read ultimately. So I couldn't say for certain if it's a bug exactly. I need to ask about it. I asked in the Discord, but it got shifted by a little bit. But I think in the meeting or at some point I'll ask Scott about it, and then. Also, I know there's a lot of work going on with USB host ultimately. So read right here, it says, the array to read data into PyUSB also allows a size, but CircuitPython only supports array to force deliberate memory use. So you're supposed to give it an array of a set size. In CPython, you can do a number, but in CircuitPython, we kept, I guess, the name, but made it so you have to give it an array. But it's unclear what the intention here is. Like, if you give it an array that's too small, is it, like, intended to clobber memory? Or, like, raise it, like, I would expect it to raise, I think, an exception maybe or something. But that's a topic for a different time. For now, we have our 64-byte thing, and I think that will stop us from clobbering anything, which will stop us from hard faulting, hopefully. Which means we can get on with what I really wanted to do last week, which was kind of make this work with game controls. Game controls. I will say though, if we do use 64, so one more thing, actually, one thing I was tempted to do, which actually this might be the way to do it. So let's set it to 64 first. Let's read once. Let's get count, and then let's update it to the size of count. Which means like, I don't know, this is kind of ham-fisted, I guess, as a way to do it. But I'm just going to make a Boolean. And we're going to say first read is true. We're going to read into our 64-byte buffer. Yeah, bytes. And then once we have the count, which I happen to know on this controller is 27, but I don't know if that's a standard. It seems kind of random. I don't know if others, like, presumably if the maximum is 64, other devices might be different. Once we read it, then we can just redefine this using the count. And what I'll do is I'll just say, actually, we want the if statement here. If first read, we do that. We set that. And I guess if we wanted to be good about it, we could try to like make a temp and put these things in. Honestly though, I don't think I super duper care that much about the data from the first read, and it's a lot simpler to just continue so that we go on to the next loop, and then we'll get the second read, which will be into the buffer that's the correct size, and then we'll do everything after that. So we skip the first one, kind of, we throw that data away, but I don't think I care. Maybe too deep, but the USB HID spec isn't too horrible to read as far as specs go. Okay, take a look through there. Get the idea. I'd open to it a lot, making a controller, but not the host side. Has to go into memory because it's a USB device. Analog read sounds easier to deal with. I mean, I wouldn't say that it has to go to memory because it's a USB device. I think it goes into this buffer, which is an array. And it was a deliberate choice to make it on CircuitPython. It was a deliberate choice to make it an array so that you have to like pre-allocate the memory for it rather than it trying to allocate memory for you. But that is just a choice about the API. However, I will say that choice is like trying to match, one of the ways that the CPython one works. So. Like it's possible it could work in a different way. It's just CPython works in those two ways, and CircuitPython adopted the one that made the most sense for microcontrollers, at least at the time. Okay. So let's save that and see if that works. Okay, so I have verbose on right now. Probably, yes, verbose true. So that's why all of this stuff came up. Which you can see a bunch of more stuff about the controller, including its serial number of 1, which is a nice touch. So the way that I have set this script up is I'm trying to like filter out duplicates. Like I really only want to know when the data changes, basically, because that's when a button got pressed or released, most likely, you know, or a joystick got moved or whatever, right? That's when user input happened. I will say with my controller, one of the things I found, which this resulted from, this ignore indexes. In fact, if we just get rid of this for now, we can see maybe. But one of the things I found essentially is that it, yeah. Well, it prints the same. Yeah, it prints the same thing every time because it's different than idle. Anyway, it's difficult to show you, I guess. But basically what's happening is one of these fields, I think it's this one. I think it's this one. One of these fields, it's actually going back and forth. There's like a heartbeat built into the data field. So when you read it one time, it's one value. When you read it the next time, it's the other value. When you read it a third time, it's back to the first value. And it just flip-flops back and forth like that, which really messes up the logic for idle, right? Because idle's trying to say, like, you know, this is what the data looks like when no buttons are being pressed, when there's no action. And then we want to compare that next time to say, like, is it idle or did something change? But something always changes because that one is going back and forth. So I added this concept, ignore indexes. It happens to be the 19th byte is going back and forth. So theoretically, we could count that over. I'm not going to do it, but whichever one is 19th, it's flip-flopping every time you read. And so I added this to be like, ignore that one when it comes to accounting for the idle. We have this like reports equal where it, in any of those indexes you put in there, it just won't consider them for when it's determining if they're equal. And the determining if it's equal is only used to do the idle stuff. And so with that turned back on, we should see that it does not spam anymore as long as I actually save the code. There we go. So we get our idle state. And then if I actually start pressing buttons, each time I press a button, we can see a new report. And in this case, the report is the full 27 bytes, which is what we ended up ultimately reading here because I set that to 64, and then we went down to the amount that we read the first time, which I happen to know was 27. Although we should probably print it. And we should not reallocate our buffer if it is not different. So if we actually read 64 bytes, then we should just keep the buffer we have. It, you know, I don't know. It doesn't really matter that much, but. All right, because like we already just hard coded it. So if count is not 64, then do that. We don't care. We always want to do first read false, though. That we don't care about. Yeah, I mean, technically, we don't have to continue in this case because we don't have a new array. We could actually just use the data, but again, I don't really care about the data. I'm just going to continue. There we go. Forgot printf. Right, thank you. Yeah, let me catch up on the chat here as well. Enough for the side. Yes. What game controller from microcontroller from what game controller or microcontroller are you trying to use out of curiosity? Yeah, good question. So I have the Feather RP2040 USB host thing. I don't know the official name. Sorry, I'll pull it up though. Feather USB. This one. The RP2040 Feather host type A. And the game controller I have is I showed it last week. Maybe that's it. Yeah, that's probably it. But I showed it last week. I suspect that this is basically the same thing. It's obviously not the exact same thing because mine is not red and mine also has different things on the buttons slightly, but it's branded the same way, TTX. It's made by the same company, presumably. These buttons look different, less like PlayStation ones, which I assume probably they might have gotten in trouble for those. I don't know. It's not red, but yeah, it seems like it's about the same thing. I think that's about what I paid for it as well. I did pull up last week one on, I think, eBay or somewhere, which was literally the exact one that I have. So if you are interested in the exact one, check the beginning, I think, of last week's stream. I had an eBay link open that was looked the exact same, pretty much as far as I could tell was the exact same controller. Okay. One of the things... So, yeah. Oops, I hit the joystick a little bit. So one of the things I'm going to do differently this time from last time, if you did watch last week, then you know I was kind of keying in on this. In fact, do I have the code from last time? With display, I do, yeah. I was doing buffer index 2. So I was grabbing the third item in the buffer, 0, 1, 2. So I was keying in on this value right here, and that changes as I press the D-pad. So I'm going to press D-pad down, and we got a new print right there, and it printed 4 in that index. So I'm going to press D-pad right, and there we got a 2. The F right here, that's because I actually bumped the joystick. One of the joystick numbers changed, and then F is actually the idle value. If we scroll back up to the idle state, we can see when no D-pad, when no buttons are pressed, the index 2 there is actually 0F. But I pressed right, we got a 2. I pressed up, we got a 0. I pressed left, we got a 6. So that changes each time, and that's what I was writing the code for last week. But one of the things I found when I started reading more data, because I was only reading 8 bytes last week, is that there's also this horribly inefficient binary representation of the data. So again, as I press a button, I'm going to press the down button. So we got our 4 right here, but we also got an FF right here. If I press the right button, we got our 2 right here, but we also got an FF right here. All of this whole section right here is either 00s or FFs, and they're basically binary, and they're basically every bit is mapped to one button, and that is actually going to be more convenient than the integer right here, because with the integer, we run into a problem of multiple buttons being pressed. So if I press down, that is 4. If I press right, that is 2. And if I try to press down and right at the same time, we got the 3 right there. Which we could add another if statement here that says if buff is equal to 3, then we know that both of those buttons got pressed, but that's going to get out of control quickly because we have, 8 different diagonals. Plus, also, you could be pressing right and left at the same time if you wanted, or up and down. Or you could be pressing 3 buttons. This area being binary means that on the one where we had 3, we actually just had 2 bits on right here. So we can just do binary masking or whatever, and we can say which bits are high. Those are the ones where the buttons are pressed, and we don't have to worry about trying to either have a massive if statement or figure out how to calculate this one that does multiple buttons numbers here. Because it doesn't seem to be the... Is it? Yeah, no, I mean, it doesn't seem to be the binary, right? We went with 4 and 2. We ended up with an integer of 3 and a binary of, the same bits of 4 and the bits of 2, but this is definitely not a binary representation of 3 that I can recognize. So, yeah, I don't know how they got this, if they just mapped them all internally or what, but these are actually going to be more handy. Even though I will say it is hilarious to me that they are so inefficient, right? Because this is actually like the number 256, right? This is like we're storing bytes to convey bits, which is just excellent. I think that's very funny to me. All right, let's get game controller, which I did not even put on here. I'm actually surprised I didn't put that on here. Game controls, there it is, okay. I already got an SCS controller from Adafruit, but I don't have a reason to use it just yet. Always handy to have a controller laying around. I don't own a gaming console, but looks like BinHex already does what you sat down and coded for. Unfortunate. BinHex? BinHex. Not sure what you mean. Like the BinHex already does what you sat down and coded for. Oh. Kind of the if statements and stuff here, essentially, sort of. Okay. So let's. All right. Okay, here we go. I actually started this last time here. So we started doing this stuff, but it's like not very much done. So we had core. We said when it gets initted, we do this thing to grab the only device. We set the configuration. And we had this dictionary. And that's the only thing that is done in here so far. And so what we need to do is implement this, which can just be a copy, I think, of that. And then that's going to call update dictionary, which is going to update this dictionary based on all of the values for these things. And in our case, the values for these things are going to come out of our read from the device. So I think we have, okay, yeah. So we have self.device. So I think what I'll do is kind of a very similar thing here. So what we're gonna do is inside of a init, let me open the other code. So inside of a init, let's just do one read. I'm gonna hardcode this for right now. I don't know if all of the devices use, like if that's a magic number that everything uses, or if that's specific to this one or whatever. I'm pretty sure that was the same number that was in the original code, so which was meant for a keyboard, so I suspect that's at least some kind of a standard. Buffers, so I'm gonna do the same trick here. We're gonna make a 64 sized buffer, and then we are gonna figure out how much we actually read and then make a smaller buffer. And then keep the smaller one and throw away the big one. We do need to make the buffer before we read. Like the binary hex weird format. Maybe it's just a hex color code appended to MSB for LED. This one I don't think has it has an LED, but I think it's always red. Well, I think there's actually 2 or 3 or 4 LEDs in there, but I do think they're all red. Or at least they've only been red that I've seen. It doesn't do Bluetooth or anything. If you were talking about one of these exactly, I don't think anything here is a color. Although I can't say that I've mapped everything. So like those two and these two are joysticks. Left joystick up, down, right joystick up, down. And then we have all of our binaries here, and then one of these is the heartbeat one. Like, yeah, here you go. You can see this one going from 0 to 1 right here. That's the heartbeat one that changes. And then I don't know what this stuff is. I guess it could be something in there. Could be a color. I don't think I've ever seen it change on this controller. Okay, we made that. We got a count, and then we just go. This time I'm going to say self.buff equals array.array. Say count. And this time I'm just going to make a new one, even if it's the same size. We're ultimately going to get rid of the first. So we get a buffer. We made our first read. Actually, we might want to make one more read to get the idle state. I think we probably want to make one more read in order to get the idle state. And actually, we probably want to add some arguments here. Maybe we should take the endpoint here. Well, no, for right now, I'm going to assume that that's kind of a hard-coded thing. But one thing I will take is the ignore indexes, which is like how I was ignoring that 19th index there. Yeah, we'll keep that. We'll get this. Let's get both of these. They don't really need to be, they can be static. I wish I could click right here and it would move my cursor, but this new thing, like, makes a phantom line that's not really a line. Of OFF. Seems like a weird way to go. More sense if it's 4 pairs of 2 bytes. So we'll say ignore indexes, and we'll put that on self. Oh, which means this does actually need to be on self. Cannot be static. Print array can be static, but report SQL cannot because it needs that ignore indexes, which I do want to be dynamic because, like, in case different controllers do different ones or whatever. Self.ignore indexes. Okay. Let's read the idle state. So this will kind of depend on you not pressing any buttons while you initialize this, because it's going to make a reading and it's going to assume that that's idle. And so if you're pressing a button, it will assume that button's down in the idle state, which won't be true in reality. But that's how I'm going to do it for now. So idle state equals, that's actually how we want to do that. We want to do it basically how I was here, which I don't really remember. How are we doing this? We're copying it with this thing. So we're going to read. So after we reallocate the buffer, I'm actually going to read again, which is going, but this time it's going to be self.buffer. And then both of these could be like this, I think. Definitely nothing else is ever meant to use that. So then self.idle state equals self.buff, copy it. So get a copy of the buffer, the current buffer, store it in the idle state, and then we'll be able to compare to that later. Okay, and then later, in the case of this is actually in here, update dictionary, we're gonna say read, first of all, so self.device.read, so we'll say count equals self.device.read. We pass it again the endpoint, pass it the buffer, and then now we're gonna say actually, do I need to compare it to the idle state? Maybe we don't actually need that right now. We might, I don't think we actually need that right now. I'm gonna leave the code for a second, but I don't think we need it, right? Because what we really want to do, like this is gonna get called, we always want this to be the current state. We don't really care, from the perspective of this code, we don't really care what the idle state is. The user code that uses this ultimately might, but inside of here we don't, I don't think. So we just read, and then we update the dictionary based on the data that we read. So in that case, we need to settle on ABXY, so let me look up some more controllers, actually. Again, this is basically the one I have. This has triangle on top, circle on the right. Let me, does I think Xbox has AB, right? ABXY? Yeah. So let's just match this. So we'll say B is circle, A is X, so B is circle, and so back to, so I kind of want, yeah, I think I want, constants for all of these indexes, basically, these addresses into the data that we're going to read. So circle button, I'm going to press circle button. I actually pressed it twice just so we get 2 copies of it here. Circle button is 0, 1, 2, 3, 4, 5, 6. So at the end of this, that one is 6. 0, 1, 2, 4, 5, 6. Yeah, that's 6. So 7, 8, 9, 10, 11, 12 is circle button. But we should call it B button. Yeah, and I totally have just spaced that. 7, 8, 9, 10, 11, 12. Okay. I want to make sure I don't get that wrong. So then the good news is I think these are all kind of next to each other, so we should have like a run of 4 essentially. So A was down. How unfortunately my headphones broke because of a naughty cat, so I can't hear your voice. Would be great if you could respond through chat instead. See, hopefully this is gonna be a person trying to sell Twitch followers. Let's see. So that was circle. X is, I'll press it twice again. X is the next one over, so 1 higher. 13. And then we'll say yx. Y is the top one. Top one. That one is actually one before the first one, so that's going to be 11 instead of 12. Then this should be probably 10, I guess, but let's press it and see. So it is weird we actually have a button with an X drawn on it, but is not the button that uses the letter X. And it's actually 14. So let's do just those to start with. Out for now, and we'll say B is self.buffer B button index greater than 0. Like, if it's 0, this will be false. If it's not 0, this will be true. In our case, it's actually just going 0 and 256 or 255, but we'll just do greater. And these are basically all going to be the same. Okay. Let's see if this actually works. Copy of that just in case we break anything. Copy of that so we could go back to it later. And then inside CodePy, we're going to change to basically this. But instead of this one, we don't want to do it like this, I don't think. We want to say dot this. Nick get called. I don't think that's right. I don't think that's right. We need to import that like this, and then we need to make game controls. Need to pass in ignore indexes. I don't need his X though. Game controls button resolved. Button state. Oh, I think I changed that, right? I think I changed that actually when we published this. And then I don't think I updated the simple test. Need to probably do that. See, this one's still button. Some of them are button, some of them are button state, which is definitely the wrong way to be. Updated like one of them. I think button state is a better name, so I'm gonna go with button state moving forward. Out of here. Have a great weekend. Yep, take it easy, DJ Devin. Thanks for hanging out for a bit. You have a nice weekend. Game controls.button state. Property. wrong. So these are inside of a knit, which is definitely wrong. Pressure. Good hardware was not automatically detected. That's fine. So that I think just prints because it tries to like, and like it says, it's trying to find it automatically. It goes through all these ones here and it does this. But I don't think we want to do all of this, right, for this one, because it takes USB core, which you might be on a device doesn't have that, so we don't want to try to import it. I think I'm fine with if you want to use this game control one, you basically don't get the convenient just import it and you're off to the races. You have to actually import the one you want, which is how the Feather Joywing would work as well. You need to import the one you want and instantiate it. I guess we could do it this way, maybe. We could do it so you don't have to instantiate it, but you still have to import it that way. Do we want to do that? Maybe. But well, actually, we can't really do it this way for the USB one because we need to pass in those indexes. Where are you from? I'm from the U.S. Midwest. Thanks for the follow. Chloe Williams 55 over on Twitch. Appreciate it, my friend. This might just be working. I haven't actually pressed any buttons yet, so let's press a button. Oh, there we go. B button, A button. That one doesn't work. That one, neither of those two work. Interesting. X and Y don't work, but B and A do. Again, there's no debouncing right now, so it's spamming really, really fast, but that's fine. I mean, it's not fine, but it's how it's expected to work. I guess makes it pretty fine. Why the other two, though? X and Y, I thought we were setting. Did we get the indexes? I got those wrong, I guess. We also tough now. Like, how about we say? Okay, it's gonna spam a lot. It's gonna spam a lot, but whatever. Let's just every time we update, let's print the buffer. It's gonna spam. What I'm gonna do is hold it down and then press. So that was the left button. And that's 6, 7, 8, 9, 10, 11, 12, 13, 14. Is okay, I'm being silly. This doesn't have X and Y. Okay. Whew. I was like, I really don't see why that would not be working. Yeah, so this code was written for Pygamer and similar, which don't have anything like the X and Y. There's no analogous buttons. There's only two buttons and a D-pad joystick. Oh, right, this person can't hear. Sorry. West US. Okay. We should be able to see up, down, but we're going to have to turn off that because that spams way too much. So I have X as left and Y as top, and I think that's correct, but I'm just going to double check. Yeah, okay. Awesome. So that's working. Really cool. Let's do up, down, left, right with the D-pad. And at some point, maybe I'll worry about the fact that we also have a joystick. But for right now, I'm just going to stick to using the D-pad. And we need to know the indexes of those. So I guess we're going to go back to spamming this. I want to say they're going to be the 4 that come immediately before those. So if you go right, left, up, down, then you get 4 in a row. Right, left, up, down. And right is index 7. So it's going to be 7, 8, 9, 10. Right, left, up, down. 7, 8, 9, 10. Right button index 7. Left button index 8. Up is 9. Down is 10. Right? Right? Oops, wrong button. Right, left, up. Yeah. Okay, right, left, up, down. So then we can easily just do these. Learn my lesson. I should just copy it. Okay. So now we should be able to see. Let's turn the spam back off. Now we should be able to see those up, left, right. Oh, excuse me. Down. Up, left, down, right. Okay. Those are all good. Start and select. And then those are the last 2 that currently are set up. There's actually shoulder buttons on this thing. There's actually joysticks also. Not going to worry about those for right now. We're just going to do start and select as well. So let's turn the spam back on. So, no, start. Oh, fascinating. So start actually does not have a bit mask over here. I'm holding start down and none of these are changing. Actually, the one that's changing is right here. Changing from 0 to 2. And select is actually just 1. Interesting. You can see the heartbeat in this 19th index going back and forth right here. Okay, so for start and select, we need to actually read the index number 1, and we need to check for either the number 1 or the number 2. Select is 1, start is 2. So start, select, ETN, index, that's actually index 1. Select, self, buff, start, select, index. So if it is equal to 1, wait, but what if they're both pressed? Do we care that much? and it's 3. So we could convert it to binary and then check the bits. I don't think I'm going to do that, though. I guess we could say if it's equal to 1 or it's equal to 3, then we know that select is pressed. And if it's equal to 2 or 3, then we know that start is pressed. And if it's equal to 0, then neither are pressed. Yeah. And then I don't... Okay, this code does actually do that. Nice to meet you. Yeah, nice to meet you as well. Okay. That works. Turn off the spam. Oh, just be error. So I actually did get that sometimes. I think that might be a consequence of like resetting it like in the middle of its read or something. I don't know the exact timing or whatever, but yeah, I don't know. I have seen that before. And it crashes and then I reset it, which is what I did right here. I press the reset button and then it's back to okay after that usually. So start and select. Select, start. Nice. Do some work for a streamer today so I can make you something cool for your channel at a reasonable price. Your Discord username, and I'll show you my recent work. I am Foamy Guy on Discord. Well, I'm numbers numbers on my Discord name. Foamy Guy. Well, if you're in the Adafruit Discord, that's the easiest way to connect with me on Discord. If you're in the Adafruit Discord, we're in the live broadcast chat. That's the chat that's right below me on the screen right here. And in the live broadcast chat, I posted a link to the stream when I started. So you can see me in Discord there. It's Foamy Guy and then a number like 28 something. I don't even really know the number. How terrible is that? I don't actually know the full username of myself. Whenever they got rid of numbers for Discord, I was like, no, I want to keep my number. So I put it in my username. But yeah, that's me on Discord. And yeah, also this person still presumably can't hear. Okay. All of those are working fine, actually, which is pretty sweet. I am going to copy this back into the repo. I'm going to go update button state inside the repo. Make a new... I probably won't make a release right now, but I'm going to update it right now, and then I actually want to try to make something with this. We might go back to the display. Yeah, I think we might go back to the display. Because I haven't hard faulted yet, so I am thinking that like this has solved the hard faulting. The fact that we're actually reading the proper amount of data now instead of having a buffer that's too small. So I'm hoping that I'll be able to interact with the display as well and not get back to hard faulting, but we'll see. The only one of these I changed is this one. I'm just going to copy this back. Overwrite. We don't need that. I'll keep that in case we want to spam more later for the rest of the buttons. And yeah, the rest of that's basically all fine. I'm going to save that. And I'm basically want to find actually all the instant... I'm just going to click through them, honestly. It's just fast. I was gonna like go grep or something. Matter. We should probably define button state inside of controls base right here as like not defined, but state, Pico system, button state, my badge, button state, gamer, button state, and then simple test, button state. All right, BRB, I'm gonna run to the restroom. I'll be right back. Okay. Okay, that's all updated, which is cool. Let's try to go back to the display. See if we can make a simple game using this, which I think would be neat. Let me untangle the slightly. Go. I'm just gonna move this for a minute. Excuse me, I'm gonna unplug this. I held my coffee a minute ago. All right. Type in chat, that'd be easy. Yeah. I don't know. I kind of typed a way to get you there. And like, yeah, I don't know. Ultimately, I guess you can't hear me. But the community ultimately that I'm more interested in growing, I guess, directly is on the Discord than the Twitch. Like, I have the Twitch chat open, I can see people, but mostly I interact more with the Discord. So going there is the way to do it. I guess maybe I could do this. We'll show. Yeah, there you go. I don't know if this person will catch on to this or not, but hopefully we'll give it one of these numbers and maybe they'll see. Of course, it was getting covered up by that, which is kind of annoying. Hopefully they'll figure that out. I'm also not trying to like make it super easy for people to spam me. Perfect. I think I want to try to make like should start basic, I think. Let's do a snake. Let's do a snake instance first. That seems easy enough. Um so I'm gonna copy this code, the game controls simple test. Back to display. Cut some of this stuff out. All of this. I don't think we're going to use rid of it in a minute. Don't really need game controller like we did in this. Set a control tab. Split that. Copy paste. So before we go all the way to snake, let's just make sure that we can draw stuff and like update it based on the controller. So let's just say we're gonna have like one circle, vector IO circle. Whoops. What that wants a pixel shader, which we don't have. So let's say palette equals palette of. Yeah, we'll start with one color eventually. Try to make that more fun, but let's just keep it there for now. Again, keep it simple. Try not to repeat last week's mistakes, basically, by going too much too fast. So we'll keep it nice and simple. One palette color, one color, circle, pixel shader, palette, XY, say like center of the screen. Separated so it's a bit easier to read. Radius 10, 5, 8. Let's see what 8 looks like. We basically had this example working last time, but it kind of was an accident that it worked because of the memory issues. So we just got lucky that it was working for a bit. This time, hopefully it can work. And A, it's a lot less code because we have game controls abstracting it now. And B, hopefully it won't be hard faulting still in this particular case. But I think if I would have like, essentially we got lucky, right? If we rearrange some of the code, it could change the layout of memory. We only really need the D-pad buttons. We don't need anything else right now. We don't need A, B, X, Y, or any of that stuff. So I'm just going to do these. And when those are true, we're just going to move the circle. So when the up button is pressed, we're going to say the Y equals the maximum of 0 and circle dot y minus 1. It will go up by 1 pixel, but it will stop at the edge of the display. That's the goal, at least. Hopefully, if I did it right, then that's what will happen. But not, then maybe it won't. We'll see. No, this time we want a plus for right. Yeah, because right's plus. So we also would want min, and we would want display dot little confused there on the old text generator, but heart was in the right spot. You can tell its heart was in the we need a group and stuff to show this. So main group, and show, well, root group, display group equal. Okay. Ever put the All right. You can drive the circle around and it stops on the edge. It might be, I mean, this is a pretty big display. I think this is like 480 by 320, which is pretty big. All right, yeah, all 4 edges work. You can move diagonal as well, which is cool. Cool. Okay, so we're moving around. We're updating the display. We're not hard faulting. All is well so far. We can close that. Let's do a bit more of Snake now. So we can get rid of some of this stuff. We don't need this. Maybe eventually we'll bring label back for a score. But for now, let's just do without. I'll do that though, just so once we do it, we have that. We'll keep terminal because we'll want font if we get back to having a label. We might want, I don't know, later array we don't need. Okay. How much of the code do I want to put in here, and how much of the code do I want to put somewhere else? I think I'm inclined to make another file called Snake Game class Snake Game. It's gonna extend group. Okay. We're also gonna have a snake. Doesn't need a super class. I guess we'll give it an XY for the starting position. And I guess we'll give it a starting size, but my intention is for that to be 1 by default. Probably always just be 1, but we'll see. So snake is going to have a direction, which is going to be equal to, actually we're going to start it on none, but then once the player makes the first move, then it will always be going in a direction. So let's make some direction constants. Direction, and just do dir direction up 0, right is 1, left down the right down around the circle there. Okay, def tick, like the game tick, and then when we do a tick, what we're gonna do is basically we're gonna move 1 step in the direction that we want to go. If we wanted to get fancy, we could make these be tuples that represent the actual change, which is kind of convenient, actually. Let's just do that. So that's 1, 0. That's 0, 1. That is 1, 0. Then we can just say, okay, so we're actually going to need some more stuff here. Self.segments is a list for I and range size. Self.segments append direction left? Come on. Makes no sense. Append a circle. We will need, again, a pixel shader, so I guess I'll just do palette equals IO palette. Actually, we'll import palette also. I don't know. I want more colors eventually. I'm gonna set this big and then I'm not gonna use it for right now, but eventually we'll get to it. Maybe. 0. Start with pink again. First, so we create that. We create a circle. Pixel shader. Palette. XY. Yeah, we'll create it. Yeah. We'll put that there. Size, we would actually want them to be somewhere other than there, ultimately. If size was... I'm not even going to do size. Size is just always 1. New rule. Size is 1 when you start. You want more size, you got to earn it by eating the apples or whatever, right? That's how this goes. Or change the code, right? That's also how this goes. I'll publish the code and you can change the code. Pixel shader, so we need radius. I don't know, 8 looks fine. Let's do that. Okay, so that will... You don't really need the for loop anymore. We create a circle, we put it in segments. We also want to put it in the group, which is, well, no, not yet we don't, because we are snake. Do we want snake to have a group as well? Yeah, I think actually I like that. So snake is also a group, and then when we append it to segments, we're also going to append it to self. That way snake game is going to initialize snake and then add it to self. Yeah. Okay, so we have one segment. That's cool. Let's just start there for now. So then tick is going to say if direction is not none, then we want to move in the direction that we're going. So self, I'm just going to say self.segments 0.x is... do we want to do the min stuff? Let's just not worry about that just yet. Traditionally in Snake, I think if you hit the wall, then you lose a life or whatever, right? Is that how that goes? Or we could Pac-Man through the walls. That could be fun, I guess. Okay, hold on here. So we have, we're going to update that to, we want to add the direction, essentially the vector we're going. So that's like self.direction, 0 for X and 1 for Y. Update the first segment. The first segment will be the head, I think, ultimately. So that's going to stay what we want to do, but eventually we'll worry about the other segments as well. So if we keep calling tick, then we should just keep moving in the direction we're going. And if we change the directions, that should change which direction it's moving ultimately. So that's like enough to start testing, I think. Snake equals snake. Self.append snake. Oh, it wants an X and a Y. Yeah, we have this problem again where really what I want is the center of the display, and I don't have access to the display. Yeah, I guess I'll pass it in here. I don't know. It feels awkward to pass a display to a group, but what I'm going to do for right now. So then here, X and Y, that's going to be display width over 2, display height over 2. And game is also going to have a tick. And inside game tick, it's going to do this basically. Game controls, so we'll go self.game controls. Side of a init here. Self, then of all of these. I'm gonna comment out the prints as well. Cry for a minute because we don't have any code now. We have a block, but what we really are going to do is when up is pressed, we're going to change the direction. So self.direction, self.snake dot direction equals snake dot direction up. Okay, so when you call game tick, it will check the buttons. If you press the D-pad buttons, it will change the direction of the snake. We will also then call self.snake.tick. And yeah, I think that's all we need. It's probably going to be way too fast. It might be really fast. I don't know how fast it's going to be. We're going to find out. Okay, so this time we're going to go different. We're going to initialize the display. We're going to initialize not the controls. Although it might be kind of cool if we pass the game controls object to the game. That way you could initialize this and use it with the other kinds of game control objects. That'd be pretty cool, actually. Eventually I will probably do that. But for now, I'm going to do it this way just to test it. We got the display. We want to create the snake game. So game equals snake game. Snake game import snake game. That takes the display. so that it can get the size and get the middle, basically. While true, game.tick. Should be all we need, I think, and that should let us drive around the single size. None is not subscriptable. Snake game 53 tick. Direction should be is not none. I never called root group anymore, so we need to. I think I'm gonna do it back out here. So after we make the game, we say display dot root group equals game. Game extends group. There we go. Okay, so we have no direction at first. We're just in the middle, hanging out. If I press... So, like, I can kind of sort of move it sort of a little. But we obviously jumped all the way to the corner. And it's also not, like, working right. Steam. Let's start by just slowing it down, because I suspect it might have gone really fast. Nope. Okay, I think I'm not updating by the direction. Instead, I'm setting it at the direction as though they are absolute points. Yeah. Okay, we don't want that. We want to say plus equals. Yeah, it's going to let us go off the screen. But we'll worry about that later. Okay, there we go. That's very slow. Let's take that sleep back out. No. Okay. Oh, then there we go. Okay. That's pretty reasonable for Snake, I think. Theoretically, we could still speed it up some by making it go by 2 pixels instead of 1. But that's fine. It's pretty good. Good enough to start with, I think. It will just keep running off the edge here. Let's make it pause. I'm a fan of like casual Snake where you can pause by just running into the wall. So instead of this, we're actually going to do yeah. So our trick with positives and negatives here is actually makes the logic of this a bit trickier. Yeah, I guess let's just do that and then it's less than 0 or it's greater than or equal to the width of the display, which I don't have access to anymore. By anymore, I mean I never had access to it because we're inside of Snake here, so we're like deep. Let's say self display size equals a tuple of, and then I guess we'll also pass that to snake. Maybe we could pass the size to snake and then it will always start in the middle. Yeah, let's do that. All right, so if it's less than x or if it's greater than or equal to the width, how about we do it this way? So we'll actually let it go one step out of bounds, but that's fine. Gonna have to change all of this around though. 0 is less than or equal to that, and if that is less than, if the x is between 0 and the width, then take step, but that's wrong because we're not gonna be able to move anymore. I'm like twisting in circles to try to avoid having to write left and right logic separately, and it's just not gonna work. Yeah, it's just not gonna work. So let's just do it. So if that's greater than width, then just set it back to the width. Well, that will let you teleport through the wall. I think I want to just go to the width. So just like stop moving if we hit the wall. And if it's less than 0, set it to 0. So that we'll hit the walls and we'll stop. This is not defined. Oh, yes. Nope. He somehow got stuck on the top. But the left and right boundaries work. He just can't go down correctly. Maybe I checked X instead of Y or something? Oh, plus equals. That thing again. Okay. F spawn apple. This is going to spawn an apple in a random location on the screen. I think I'm just gonna go self.apple equals. We're just gonna make this right at the beginning here. Head circle is gonna be pixel shader, Apple palette, and then XY. I'm just gonna start on 0. We're gonna move it in a minute. Radius, also just as is the snake. Go a little. Tiny bit. Self.append. So it's visible. So then spawn apple is actually just going to move the apple to a random location. Self.apple.x equals random.randint. And I'm just going to say 10 and the size width is 10. Gotta spell it correctly. Height. So that will move it to a random location. And we'll just reuse the same apple and always just move it to a new place when we need. So let's make sure that works. We should be able to see an apple on the screen now. Yep, there's the snake, there's the apple. We want to check if we have touched, like if the head of the snake, like if we eat the apple basically. So if the head of the snake touches the apple, that's when we know that it got eaten. We are going to check that inside of game tick after the snake moves. And we know the snake's head is always snake.segments0.xy. So we need circle collision detector, actually. Thank you. Not polygon, though. We want circle. Circle. Get the distance between the two circles, and then Pythagorean theorem. Well, no, Pythagorean theorem gets you the distance. And then if the distance is less than the 2 radii. Okay. So let's make a function def eating apple for snake apple collision. Okay, that was very messed up. Okay, so distance x equals circle 1x. So we'll say circle 1 is snake self.snake.segments 0.x. Circle 2 is the apple, self.apple.x. Don't need these. Self.snake segments 0 y dot apple dot y. I think math dot square root, maybe. Actually, didn't I add a math dot dist? Add that? I don't know. I thought I had that for the collision stuff. I guess maybe it didn't stick because I ended up closing that. Maybe it was part of the same PR or something. We'll just use square root though, math dot square root. So that's distance, and then we basically just want to check if the distance is less than the two two radiuses. So self.snake segment 0.radius plus apple.radius. So if it's less than or equal to those, then they are touching. Actually, just so then we'll say inside of game tick, after the snake tick, we go self.snakeApple collision. If that is true, if they are colliding, then we're going to say spawn apple again. So that's going to move the apple to a new place. Eventually, we'll worry about making the snake bigger as well. One thing at a time. Nice. All right, so we can drive this around and we can eat the apples. Now we want to get bigger each time we eat an apple. And in order to do so, I think we can have def row actually, I think what I'm gonna do is self dot I'm gonna do self dot needs to grow. That's gonna be a boolean. It's gonna start on false. And then if this was true, we will also set it to true. Because this is after the tick, and so what I want to do is the next time we tick is actually basically when we're going to grow. So then inside of tick, we actually need to start worrying about the fact that we're going to have more than one segment. So this moves the head. And I think what we want to do is actually hold a temp x equals the position of the head. I need to return from inside of here. I'm gonna see. Getting ahead of myself again. Okay, so that is the current before we move position of the head. So that is gonna be the old position of the head after we actually move with this code here. And then what we want to do is basically go through all the segments and move them to the temp location, but then also update the temp location to... We actually need another one of these. I'm gonna call these previous? Kind of a little bit, but kind of fits in my head, sort of. So that's actually going to be previous X, previous Y, or just prev, shortened to prev. Previous X, previous Y, and then what we're going to do is for I in range, we're going to start at 1, we're going to go to the length of segments, and then we're going to say that segments I dot X. No, first we're going to say temp X. Here's why we need a second one of these. We can store that there. Then we're going to go segments I X equals prev. No. Just prev. And then prev Y. And then after that, we go and update prev values. So prev X equals temp X. Previous Y equals temp Y. So each one will move to where the one that's one lower than it in the list was. And then, after we have done all of that, if we need to grow, first we put that to false. Then we are going to add a new circle. The new circle is going to be at where the tail used to be, which is now prev X and prev Y, because we've been through this loop. So make a new circle, put it in segments, and then put it in the group. I think that might work. So it will take a minute to see it's actually working, because we're only growing by basically 1 pixel. Hey, we lost a pixel back there. That's interesting. Yeah, I'm pretty sure it's working. Yeah, it's totally working. Sweet. Okay, so we made Snake, and it works. We're getting longer. I don't know, it might not be practical. Like, I can already tell the snake is slowing down. Also, we keep losing pixels like that, which is interesting. I think if I can eat that by, because it'll refresh, basically. Yeah, so we're definitely are slowing down quite a bit, honestly. As we get more circles, but pretty good. It's probably worth doing a tile grid implementation, which I actually have done before, honestly. So this is vector IO, and it's slowing down essentially linear with the number of circles that we have. Each time we eat an apple, we add a circle, and then we're slowing down a little bit. So, like, one thing we could do to speed it up some is just fewer circles. So instead of having the segments of the snake be a circle that are just 1 pixel apart from each other, they could be further apart, which would mean fewer segments get you a longer snake, which would make the game kind of progress faster, because it would get harder faster, because it's harder the longer your snake is. Although at this point we don't have any logic that that makes you lose if you run over yourself. Are we going in an angle? I thought for a second we were moving at an angle. I think it's just because the display is at an angle relative to the camera. I know. All right. Well, anyway, it's a functional snake. That would be one way to speed it up, is use fewer circles, which would mean kind of making the snake longer by making the circles farther apart quicker. Oh, that's interesting. We went all the way off the edge. Is segment 0 not the head? I thought segment 0 was the head. But it seems like it's letting us get all the way past the head to the tail. Huh. Segment 0? Maybe it's backwards from what I thought. I don't know. That's weird. I thought the head was going to always be 0, but it seems like maybe the tail is 0. But anyway, it's functional. It slows down. Separating them apart would make it faster. The other thing truly that would make it faster, and what I think is probably what I'll do, but it's kind of the correct solution, I think, in terms of display I/O to make it as fast as it can be, is this whole thing could be a tile grid instead. So then our grid would be like 16 by 16 pixels instead of 1 by 1. So everything would be a lot faster because the rendering won't have to be dealing with individual pixels nearly as much. So yeah, I'll probably do that at some point, perhaps next week on the stream, perhaps sooner, I'm not sure. But in any case, I think that's probably going to do it for now. We have been going about 2 hours, which is usually about how long I stream. So I will wrap it up, I think. I am pretty happy that we got the game controls implemented with HID controller, and that we were able to make a very simple kind of proof of concept game with it. Definitely room for improvement, but we're getting there. Yes, those are stuck pixels. Yeah, they totally are. Yeah, if I drive the snake over them, they'll go away because of the display refresh, but they are totally just stuck. So that is either a bug with vector I/O or a bug with display I/O. Yeah, one of those two though is causing those to get stuck. And then when you drive over them, they refresh and so they go away. But until they refresh, they'll stay on. Which is a bit odd. All right, take it easy, everybody. I hope y'all have a good rest of your weekend and a good time in general. I will be back next week, I'm pretty sure, at the usual time, 10 a.m. Central Time. If you are a CircuitPython meeting attendee, remember we are on Tuesday this week, U.S. holiday on Monday, so we're bumped to Tuesday for the meeting. I'll see you on Tuesday for that if you are. Otherwise, farewell, so long. Thank you for watching.